You're listening to leadai.dev, your daily updates on AI development. Today's topic is VISOR. New agentic visual RAG system solves multi-page reasoning. Here's a quick overview. VISOR introduces agentic visual retrieval-augmented generation that connects evidence across multiple pages, solving critical bottlenecks in document reasoning systems. Now, let's ask our analyst about these developments. What's new? VISOR agentic visual RAG system architecture?
Researchers have unveiled VISOR retrieval-augmented generation via iterative search and over-horizon reasoning, a breakthrough agentic system that addresses fundamental limitations in visual document analysis. The system tackles two critical bottlenecks that have plagued existing visual RAG implementations. Visual evidence sparsity, where key information is scattered across multiple pages but processed in isolation, and the inability to perform effective cross-page reasoning. VISOR introduces an iterative search mechanism combined with over-horizon reasoning capabilities that enable AI systems to connect evidence across document boundaries, fundamentally changing how vision language models approach complex multi-step queries. The technical architecture centers on an agentic framework that interleaves reasoning with iterative retrieval operations. Unlike traditional visual RAG systems that process pages independently, VISOR maintains a dynamic evidence graph that tracks relationships between visual elements across the entire document corpus. The system employs specialized visual encoders optimized for document understanding, coupled with reasoning modules that can maintain context across multiple retrieval cycles. This approach enables the system to identify relevant visual evidence on distant pages and synthesize findings into coherent responses for complex analytical queries. Previous visual RAG implementations suffered from context fragmentation, where relevant information spread across multiple pages remained disconnected during the reasoning process. Traditional systems would retrieve individual pages based on query similarity but fail to establish connections between related visual elements appearing in different locations. VISOR's over-horizon reasoning capability specifically addresses this limitation by maintaining a persistent reasoning state that accumulates evidence across retrieval iterations, enabling the system to build comprehensive understanding from distributed visual information sources. Iterative search mechanism that performs multiple retrieval cycles while maintaining reasoning context over horizon reasoning that connects visual evidence across document boundaries and page separations, dynamic evidence graph construction that tracks relationships between visual elements throughout the corpus, specialized visual encoders designed for document-specific understanding rather than general. Image processing agentic framework that adapts retrieval strategies based on intermediate reasoning results.
Thank you for that analysis. Let's move on. Who benefits from VISOR's multi-page visual reasoning?
Enterprise document analysis teams working with complex multi-page reports, financial statements, and technical manuals will see immediate benefits from VISOR's cross-page reasoning capabilities. Organizations processing regulatory filings, research papers, and legal documents where critical information spans multiple pages can now deploy AI systems that maintain context across document boundaries. Development teams building document intelligence applications for industries like healthcare, finance, and legal services gain access to reasoning capabilities that were previously impossible with isolated page processing. Teams managing knowledge bases with visual content, including technical documentation and training materials, can implement more sophisticated query systems. Research institutions and academic organizations analyzing large-scale document collections will find VISOR particularly valuable for literature reviews and systematic analysis tasks. Data science teams working with mixed media documents containing charts, diagrams, and textual content can leverage the system's ability to synthesize information across visual and textual modalities. Business intelligence teams analyzing quarterly reports, market research documents, and competitive analysis materials benefit from the system's capacity to connect trends and patterns across multiple document sections. Organizations with limited AI expertise or those requiring immediate deployment should consider waiting for more mature implementations. Teams working primarily with single-page documents or simple text-based queries may not justify the additional complexity. Companies with strict latency requirements for real-time applications should evaluate whether the iterative retrieval process meets their performance constraints, as the multi-step reasoning approach introduces computational overhead compared to single-pass retrieval systems.
Great insight, really helpful context. How to get started. Implementing VISOR step by step?
Implementation begins with setting up the document preprocessing pipeline that extracts and indexes visual elements across your document corpus. Install the required dependencies, including specialized vision language models, document parsing libraries, and vector database systems capable of handling multimodal embeddings. Configure your document ingestion workflow to maintain page-level metadata while creating cross-references between related visual elements. Establish the evidence graph database that will track relationships between visual components across different pages and documents. Deploy the iterative search components by configuring the query processing pipeline that breaks complex questions into subqueries for sequential retrieval. Set up the reasoning state management system that maintains context across multiple retrieval cycles, ensuring that evidence from previous iterations informs subsequent searches. Configure the over-horizon reasoning module with appropriate similarity thresholds and relationship detection parameters. Implement the evidence synthesis layer that combines findings from distributed visual sources into coherent responses. Test the system with representative multi-page documents from your target domain, starting with queries that require information from 2 to 3 pages before progressing to more complex cross-document reasoning tasks. Monitor the evidence graph construction to ensure proper relationship detection between visual elements. Validate that the iterative search process terminates appropriately and produces comprehensive responses. Fine-tune the reasoning parameters based on your specific document types and query patterns to optimize accuracy and response quality. Configure document preprocessing pipeline with visual element extraction and cross-page indexing capabilities. Set up evidence graph database with multimodal embedding support and relationship tracking. Deploy iterative search engine with query decomposition and sequential retrieval mechanisms. Implement reasoning state management for context preservation across multiple retrieval cycles. Establish evidence synthesis layer for combining distributed visual information into coherent responses. Configure over-horizon reasoning parameters for optimal relationship detection and context maintenance.
That's a very interesting point. Tell us about competitive context. VISOR versus existing visual RAG solutions.
VISOR distinguishes itself from existing visual RAG systems like Llama indexes multimodal capabilities, and LangChain's document loaders through its agentic architecture and cross-page reasoning abilities. While traditional systems like GPT-4v with RAG extensions process documents page by page, VISOR maintains persistent reasoning state across multiple retrieval operations. Microsoft's Florence and Google's Pix2 struct focus on single image understanding, whereas VISOR specifically addresses multi-page document scenarios. The system's evidence graph approach surpasses simple vector similarity matching used by most current implementations, enabling more sophisticated relationship detection between visual elements. The iterative search mechanism provides significant advantages over single-pass retrieval systems commonly used in production environments. Unlike static retrieval approaches that depend on initial query formulation, VISOR adapts its search strategy based on intermediate findings, leading to more comprehensive evidence gathering. The over-horizon reasoning capability addresses a fundamental limitation in existing systems where context gets lost between page boundaries. This approach enables VISOR to handle complex analytical queries that require synthesizing information from multiple document sections, a capability lacking in most current visual RAG implementations. However, VISOR introduces computational complexity through its multi-step reasoning process, potentially increasing response latency compared to single-pass systems. The evidence graph maintenance requires additional storage and processing overhead that may not be justified for simple query scenarios. The system's effectiveness depends heavily on the quality of visual element extraction and relationship detection, which may require domain-specific tuning. Organizations with straightforward document retrieval needs might find traditional RAG systems more cost-effective and easier to maintain.
Good analysis. Let's continue. What's next? Future implications for visual document AI?
The research trajectory suggests integration with large language models will expand VISOR's reasoning capabilities beyond document analysis into complex visual problem-solving scenarios. Future iterations will likely incorporate real-time learning mechanisms that improve evidence relationship detection based on user feedback and query patterns. The development roadmap indicates potential expansion into video analysis and temporal reasoning, where the over-horizon concept could apply to frame-by-frame understanding in multimedia content. Integration with enterprise document management systems and workflow automation platforms represents a clear commercialization path. The broader ecosystem impact points toward standardization of agentic visual RAG architectures across different domains and applications. Integration possibilities with existing AI development frameworks like Hugging Face Transformers and OpenAI's API ecosystem will likely accelerate adoption among developer communities. The evidence graph approach may influence how other AI systems handle multimodal reasoning tasks, potentially establishing new architectural patterns for complex document understanding applications. Long-term implications suggest VISOR's methodology could reshape how organizations approach knowledge management and document intelligence. The ability to reason across visual boundaries opens possibilities for automated report generation, compliance checking, and research synthesis that were previously limited by single page processing constraints. As the technology matures, expect to see specialized implementations for specific industries like healthcare imaging analysis, financial document processing, and legal case research, where cross document reasoning provides significant competitive advantages.
Great analysis. So, what are the key takeaways from all of this?
VISOR solves visual evidence sparsity by maintaining reasoning context across multiple document pages through iterative search. Implement evidence graph databases to track relationships between visual elements distributed across document boundaries. Configure over-horizon reasoning parameters to optimize cross-page information synthesis for your specific document types. Test with multi-page queries requiring 2 to 3 page evidence before deploying on complex cross-document reasoning tasks.
And what market signals should our listeners watch for?
Enterprise Document Intelligence Acceleration. VISOR's cross-page reasoning capability addresses a critical gap in enterprise document processing workflows, particularly for organizations handling complex multi-page reports and regulatory filings. The ability to maintain context across document boundaries enables more sophisticated automation of compliance checking, financial analysis, and legal document review processes. This breakthrough positions visual RAG systems as viable alternatives to manual document analysis in high-stakes business environments where accuracy and comprehensiveness are paramount. AI Development Framework Evolution. The agentic architecture and evidence graph approach introduced by VISOR signals a shift toward more sophisticated reasoning mechanisms in AI development frameworks. Traditional RAG implementations focused on similarity matching are being superseded by systems that can maintain persistent reasoning state and adapt search strategies based on intermediate findings. This evolution suggests that future AI development tools will prioritize iterative reasoning capabilities over simple retrieval mechanisms, fundamentally changing how developers approach complex problem-solving applications. Multimodal AI integration maturity. VISOR represents a maturation point in multimodal AI where vision and language capabilities are being integrated at the architectural level rather than as separate processing pipelines. The system's ability to synthesize visual and textual information across document boundaries indicates that multimodal AI is moving beyond simple image captioning towards sophisticated analytical reasoning. This progression suggests that enterprise AI applications will increasingly require integrated multimodal reasoning capabilities rather than specialized single modality solutions.
What should developers and operators do with this information?
Evaluate current document processing workflows for multi-page reasoning requirements before Q2 2024 implementation planning. Set up VISOR pilot testing with representative document samples containing cross-page evidence dependencies within 30 days. Configure evidence graph databases and iterative search parameters for domain-specific document types by month end. Deploy production systems with over-horizon reasoning capabilities for complex analytical queries requiring 90-plus day implementation cycles.
Thank you for listening to leadai.dev. Stay tuned for our next daily updates in this rapidly emerging market.